So for this part of predicting redox reaction, what we will see is how can we use the table and more complex questions into predicting reaction, most likely when the compounds are not given or things like that. Okay, so remember what we have said in terms of the oil rig. So oxidation is losing and the reduction is gaining. And then whatever element is losing is becoming a reduction agent, and whatever element is gaining is becoming the oxidation agent. Okay, I remember this all the time when we are working with anything in pretty much everything in electrochemistry. So the first thing is let's identify if a magnesium 2 plus when it reacts with, let's say, nickel, is it spontaneous or non-spontaneous? And then let's say that bromine gas is reacting with iron, is it spontaneous or non-spontaneous? And the third one, when chlorine is reacting with gold, is it spontaneous or non-spontaneous? And last one is a tin 2 plus reacting with copper. Is it spontaneous or non-spontaneous? Okay, so now let's take a look at the table that you have on your data booklet on page 7 and see if when magnesium 2 plus is reacting with nickel, then we will have or not a reaction. Keep in mind what we have said so many times, that whatever is on the left side of the reaction is the oxidation agent, and whatever is on the right side is the reducing agent. So when we see magnesium 2 plus, magnesium 2 plus is somewhere in here, and it is an oxidation agent. So now we take a look at the nickel, which it should be in the reduction on the side of the reduction agent, because if we have two oxidizing agents, then nothing is happening. And nickel, I saw it, is here. Okay, so now since we have this magnesium 2 plus trying to aim to nickel, then since it is going up, then it is a non-spontaneous reaction. Okay, so since it is not a natural flow. Now you can use the other method on working with the electric potential difference. So you can have this plus 0.26 Y plus, because you are flipping the reaction, then will be a negative value, which means that is a non-spontaneous reaction. Now let's take a look at the other one. I will delete those so that we have a clean table. So now we see bromine 2 and iron. Are they spontaneous or non-spontaneous? So bromine is, you just have to find where they are. Okay. So bromine is here and is on the oxidation side of it, and iron we have to look for on the reduction agent side of it, and it is somewhere in here. So when you try to see what is happening, how can you connect those two from the oxidation to the reducing agent, then it's a natural fall, which means that this is a spontaneous reaction. Okay, so again, you can see the other method that I had on the previous video of predicting redox reactions, in which you deal with the voltage values. Next one is chlorine to chlorine gas. So chlorine gas and gold. Okay, so let's find those two, and then they see if they are spontaneous and non-spontaneous. I will leave it up to you to figure out that, but I'm telling you that this is a non-spontaneous reaction. Find those two and then see that is a non-spontaneous reaction. It is interesting fact when we see that tin 2 plus and copper are reacting together, because when we see copper is this one here. And when we see tin 2 plus, we see it in two places. Okay, we see it here. I will circle it in the reducing agent, and we see it at the tin 2 plus here at the oxidation agent. Now, this is where you may be like, oh, which one do I have to get? Now, if you are looking for copper and tin 2 plus, one has to be a reducing agent and the other one has to be a oxidation agent. They cannot be two, both reducing agent or oxidation agent, both oxidation agents. So one has to be a reducing agent and the other one has to be an oxidation agent. So that means that we ignore this one here, and what we do is we take this reaction into the consideration and say that since the drop is not natural, because we move from the oxidation to the reducing agent and the drop is non-natural, that means that is a non-spontaneous. But you have to figure out which one are you taking into the consideration, this or this reaction or this reaction, and then you have to see that if copper is a reducing agent, then it should be an oxidation agent to take into the consideration. So you'll have to pay attention to transition metals, because transition metals, let's say iron. So if it is iron 2 plus, it can be iron 3 plus or just iron. Okay, so you have to look, and you will see those in both sides, but you will pick the side that fits you the best. So if you are looking for an oxidation agent, you have to look at the left side, and if you are looking for a reducing agent, you have to look at the right side of the reaction. Okay, so just pay attention to this. Now we'll see something that is kind of a matching game, where we do not have the values and we do not see so we don't have the values nor the compounds. I will draw the table and then deal with it in a second. So you will see something like this when you have A, B, C, D, or W, X, Y, Z, and a list of ions that are like this in the table here. So what do we see is that the reaction between each other is non-existing, because what is happening when you are combining A and A minus? Nothing, pretty much. But then the evidence of reaction is happening when A and B is uh, A ion and B are reacting together, or A and C are reacting together, but there is no evidence when A and D are reacting together. And so this cross means that there is no evidence of the reaction, but there is an evidence of a reaction when there is a check mark. So now types of questions that you will see will be either list the, I will write here, list the strongest oxidation agent from, list the oxidation agent from strongest to weakest, or list the strongest reducing agent from strongest, reducing agents from strongest to weakest, or predict if will happen, predict, let's say that you have an A and D is happening. Okay, predict a certain reaction. So the very first thing that we have to do is we have to identify which one are reducing agent and which one are oxidation agent. When we see those ions here, based on either Leo or oil rig, Leo the lion and oil rig, we can say that those are reducing agent. So therefore, A, B, C, D will be an oxidation agents. Okay, so when we are sorting them, we will sort what is A, B, C, D when we are sorting the oxidation agent. Okay, so now let's see and create that table. Okay, so we will, another thing that you may see and may use here is that reducing agents are metals. So when we see that is negative, then we know that they are metals. Okay, so let's sort them now from, let's create the table, which is similar to the table on page 7 of your data book. So now we have, we'll start with from this oxidation agent from the strongest to the weakest. And then on the other side of it, we will have the reducing agent from strong in the bottom to the weakest. Okay, so let's see the first one. So we see that from the table here, that A is reacting with it's A is gaining electrons and reacting with B and C. Okay, and B is reacting only with C, and D is reacting with A, B, and C. So when we see the oxidation agents A, B, C, and D, we can draw the conclusion that this is reacting with 1 because we have 1 check mark here. B is reacting with 2, and the C is reacting with 3, and D is 0, reacting with no one. So from the strongest to the weakest oxidation agent will be C will be the strongest one, and then D will be that has 3, reaction. B will be the next one. A will be the third one, and the last one will be D. Okay? Make sense? Excellent. So let's put now this into the table, which is similar to the table that we had in our data booklet on page 7 from the strongest, which is C. So C will be here, and then B will be here, and then A will be here, and then the last one will be D, oxidation agent. Okay, now let's write the equations for them. I will write the equation, and then you will see the equations written. You stop the video and then write the equation and check it with my. So you should have a table that looks like this, in which you are sorting the oxidation agents from the strongest to the weakest, and the strongest one being C, B, A, D, and then you write the equations, while for the reducing agent, you go from the strongest to the weakest up, and then when you are sorting the reducing agent, then so strongest reducing agent to the weakest reducing agent, the order will be D -3, the first one, A minus, the second one, B -2, the third one, and the weakest one will be C -2. Pay attention to what they are asking, from the strongest to the weakest, or from the weakest to the strongest, because that is important. Another question that they may ask on those kind of things is that when they are giving you some order and then they are asking you, will this be a reaction? So this is the predict one. Will this happen or not? So then what you have to do is you have to build the table, and then you have to see, okay, what is happening here between C and D. Okay, so C and D, then we have C is in the C -2 is here, and then D is here. So now when we are moving from the oxidation agent to the reactant agent, the jump is not natural, it's not a flow. So C and D, C2 minus and D is a non-spontaneous reaction. So this will not happen naturally. This is the most complicated questions that you will see into predicting redox reactions, when you have a bunch of equations, which, as you notice, even from the screen, they are not in your page 7 of the data booklet, which means that you will just see and identify the order of oxidation agent from weakest to strongest, or from strongest to weakest, the order of reduction agent from weakest to strongest, or from strongest to weakest one, and then you will predict if a certain reaction is spontaneous or non-spontaneous. So what we will do in this case, since we have the reaction happening here for first, second, and third, so those are not given on your data booklet. If you take a look at it, then they are not given. Since this reaction is happening, then we can assume that this is a spontaneous reaction. Even the second one is a spontaneous reaction, and since we do not see any evidence of the reaction, then we can draw the conclusion that this is a non-spontaneous reaction. Great. So now let's create a table that is similar to the table that you have on page 7 with those 4 uh, elements so that we are dealing with. Okay, so we have cobalt, we have copper, we have um, PD and iron. Okay, indium, whatever is it. So since we have a spontaneous reaction that is happening, first of all, sorry, we will sort on the left side, we will sort the oxidation agent, and on the right side, we will sort the reducing agent. So on the first one, we have a spontaneous reaction. So what it is happening is that cobalt 2 plus is below in the order of the then thank you. Thanks. So copper, copper 2 plus is above iron, because we have to have that natural flow of the water or electrons. So if we write now the reaction for copper 2 plus will be copper plus 2 electrons, then we'll have copper here, we'll write it copper here. Okay, and then if we take a look at the iron, then we will have iron 3 plus, because this is what we have here in the reaction, 3 plus, and if it is a multivalent one, then 3 electrons, so we'll have this reaction here. Okay, so the first one is dealt because we have copper above 2 plus and iron below, so it's a spontaneous, telling us that we have a reaction happening. Okay, great. So now we have cobalt and copper. So copper 2 plus and cobalt are reacting together because we see evidence of the reaction. That means that cobalt is, I will write it with a different color. Cobalt is below copper 2 plus. So copper will be, cobalt will be somewhere in here. And now since we have cobalt 2 plus, then we can write the equation as cobalt 2 plus plus 2 electrons will give us this. Great. Now, the third one is that we don't have an evidence for reaction between copper 2 plus and PD. Okay, now that means that we can use copper 2 plus, we can use copper 2 plus as a pivot. Where is it going? So since it is not reacting, that means that PD is above copper 2 plus in the reactant agent side of it. So PD will be somewhere in here. Okay, and now we are assuming that it is PD2 plus. So when we write the equation, PD, not PB, sorry, PD2 plus, we're assuming that it is 2 plus, but it can be 3 plus as well, because it is quite valid as well. So now, if we are sorting the strongest oxidation agent to the weakest oxidation agent, then the order will be strongest will be Pb2 plus, and then next one will be copper 2 plus, cobalt 2 plus, and iron 3 plus. And if we are sorting strongest reactant reducing agent to weakest reducing agent, then we will go IN is the first one, the strongest one, and then it goes to cobalt, and then copper, and then PD, not PB. It's PD. Okay. Now let's see and predict if this will be a third type of question that you may see. Predict if a reaction or the evidence of the reaction will happen when we have copper 2 plus and iron. Is it spontaneous or non-spontaneous? This is pretty much what we are seeing. So then we take a look at the table that we have here that we created, this table here. And then we see we are standing at copper 2 plus, and we are moving to on the oxidation agent, and we are moving to ion in the reduction agent, so that means that is a spontaneous reaction. Okay, we'll do more questions like this in class, but those are pretty much what we have to keep in mind when we are predicting redox reaction. And this concludes this series of lessons for day 2, conclude the predicting reactions. I will see you in class.